All right, so I begin with the Pythagorean theory. So the Pythagorean theory, okay, and there was two statements actually there. That's when the theorem and the converse. Okay, so that what does that mean? That means if it is a right triangle, then the three sides satisfied by satisfying the following equation. A squared, okay, plus b squared equals c squared. Okay, so this is if it is a right triangle. The converse part says that if a squared plus b squared equals c squared, then this is a right triangle. Okay, then it's a right triangle. So this is so the complete statement will be it is a right triangle if and only if a squared plus b squared equals c squared. Okay. And the history says that I learned from history, okay, that actually Chinese discover this special right triangle. If this side is three, that side is four, and the surprise, this will be five. Okay, but when you find this special right triangle, many people just stop there. Okay, great, I find it interesting, right? And then maybe 100 years later, another person discover this special triangle, 5, 12, and 13. Okay, and just by accident sometimes, you measure, you walk to the north 5 steps, or then you walk to the east 12 steps, then you find out that they are about 13 steps away from each other. All right. So most of people will just stop that. Okay. Then maybe someone, okay, will pay more attention and ask the question, is this always true? Because you see that, right? 5 square, the hypotenuse, right? It's 3 square plus 4 square. And here 13 square is giving 5 square plus 12 square. So when you see this pattern, you ask yourself, hey, maybe this is true in general. Once you ask this question, then you probably halfway to be successful. Okay. So then later, and you do get uh yeah, then if then maybe you can figure out how to prove it. So I'm going to give you a very simple proof. There are many ways to prove it. Okay. So how do you do that? Well, I put the right triangle in the following way. Yeah. Okay, this is right triangle, and this side is A, this side is B, this side is C. Okay. Then I draw the line, and this is at altitude from the right angle vertex, okay, to the hypotenuse. So this will be X, this will be Y. So right, so X plus Y equals C, right? Okay. Then you find out there's the triangles are similar. Okay, so this triangle, for example, I put it here, and this will be X, this will be A, right? And this will be H, and the H, right? So this is a triangle, and the other one will be okay. So this will be H. I think this will be Y, right? Right? I flip it over and put it aside. Okay. So those three triangles are similar, right? This triangle Y similar. I think, the corresponding angle is the same. Okay. So they are similar. Then you have the ratio B, uh, like for example, compare this two, right? Compare this two. The ratio of the corresponding sides, right? So that would be like B over X, right? Equal, no, not B over X. Yeah. Let's check. B to B to X, not A to X. Yeah, let's check. So A to C, right? Let's go this way. A to C or C to A, okay? So C over A is these two sides. Okay. No. Those two triangles. Yeah. Yeah. Those two sides, right? A to C, and then A over X. Okay. I needed that. I don't need to compare the other side. Okay, that's the first one. Right? From here, you get A square equals CX, right? Then you look at those two triangle. Okay. So C to B equals B over Y. Okay, right? And then you will get B square equals C times Y. Right? You get this identity. Okay. And then you find out A square plus B square equals CX plus CY, and they have a common fact, and X plus Y. And X plus Y is nothing but C, right? We already know that it's C. Okay, so that's the C square. Okay, so that is identity. So A square plus B square equals C square. Okay, we use a similarity of triangle. Okay. So we accept this. And then I play with those numbers. We have the very interesting formula, algebraic formula. This is the algebraic formula, okay? A plus B square, okay, is going to be A square plus B square. Okay. Okay, then plus 2AB, right? And you know that A square plus B square is C square, right? And then A plus B, okay, let's see. I'm going to denote by the area. I'm going to use A. That is the area. So area is half of A times B, because take a look at this above right triangle, okay? Yeah, half of A. And then this will be 4A, right? So this is an interesting identity because from here, A plus B equals square root of C squared plus 4A, right? And then if you add C to the both sides, you get C squared plus 4A and plus C. And this is a parameter. So P equals A plus B plus C, and this is a parameter. So this is identity. And this identity tells you that if you know two of them, you can get the third one. Okay, so if you know the area, if you know the length of hypotenuse, then you can get the parameter. Okay, just they all come from this algebraic formula, right? All right. So now earlier I mentioned that we find out some special formulas, right? Some special triangles. Okay. So this is 3, that's 4 and 5. And another triangle, we know that is going to be 5, 12, and 13. Okay. So you're wondering, is there any other right triangles? Okay, was those are integers, right? Integer lengths. Okay. So when we say a Pythagorean troop is a troop of positive integers A, B, C satisfy the equation A squared plus B squared equals C squared. So we are looking for three numbers so that A squared plus B squared equals c squared. And I suppose you're a teacher, right? And you only know those two special right triangles with the integer length, and you want to make another one. You have to think about that. How can I figure it out, right? You cannot just try, guess and try. It takes forever, right? Right? So that there was that's a question. Yeah, you cannot just okay. You learn that from the textbook. You saw this too, right? And the question is, can you find more, and how to find them? Okay, how to find them? Well, it is surprised if you let A to be m squared minus n squared, B is 2mn, C equals m squared plus n squared. Then you find out, all right? So here A, B, C are three variables, m, n are only two variables. Then you find out A squared plus B squared is going to be C squared. Okay, and you can check easily because you're on this side. Let's check, right? Here's m to the fourth power minus 2m squared n squared plus n to the fourth power. Here's 4m squared n squared. And the right hand side, all right? So you compare both sides, you find that they're equal. Okay, so that means let me draw the picture here. That means if this is always the right triangle. If this side is m squared minus n squared, and here's 2mn, and here's m squared plus m squared. So you have two variables, n and m. N and m are arbitrary. Okay? When n and m okay, here m is greater than n, otherwise it would be negative, right? And then yeah, m and integers, are positive integers. All right. So now, yeah, I got thousands of triangles because m and n can be arbitrary integers. As long as m is greater than n, then m squared minus n squared will be positive. And you can choose a special value. Okay, you can choose a special value. And for example, yeah, there are lots of several. Yeah, you can choose a special value for mn. And for example, m equals 2, n equals 1, right? Then what do you get? 2 squared minus 1 is 3, right? And the 2 times 2 times 1 is a 4. And 2 squared plus 1 is just 5. So that's what you get. All right. All right, so let's take a look at some exercise. Okay. So here's a question. A right triangle have a hypotenuse 2 and the area 1. Find the perimeter. Right? So we already know that, right? This is a 1, hypotenuse 2, okay? So the area equals 1. Find the parameter P. Okay. Now, if you forget the formula, then you have to do it again, step by step. Okay. So if you forget formula, if you know the formula, then it's easy, right? By the formula, P is going to be square root of C squared plus 4 A plus C, right? And that is formula. Then you just plug them into the formula. C is 2 squared, 4 times 1 plus 2. Okay, 8 is 2 squared root 2 plus 2. Okay. Now, if you don't have the formula, if you forgot the formula, then you have to introduce the variables and you have to use, yeah, here's the A and the B, right? Then you know a couple formulas, a squared plus b squared equals 2 squared. That's not enough, right? This is a hidden form identity because it's a right triangle. And you know the area is 2, so 1/2 times AB equals 2. And you have to find out P equals A plus B plus C, right? So you already know C is 2. You just find A plus B. And you can also find out, just look at those two equations. You don't need to find A and B, but you still can find A plus B, right? Then you solve the problem. Okay, so either you know, maybe you derive the formula by yourself, you memorize it, you can quickly find an answer. Or you have to use the same idea we used for the formula, and then you solve the problem. Okay. All right, so take a look at second problem. A right triangle has perimeter 120 and altitude 24 to the hypotenuse. And can you find the area? Right, so step one, you draw the right triangle. Right, you can draw it in the, probably you can draw it this way, right? This is right triangle. Okay. And this side is A, this side B, this side is C. Okay. Because it's right triangle, there's a hidden equation there. A squared plus B squared equals C squared. So you write down that. Then write down what is given information. You are given the parameter. Okay. But now you have the altitude. So H is going to be 24. Okay. So those are the given information. And then you need to find out the area. Area is half of A times B. So there are lots of variables here. Okay. There are lots of variables here. Yeah, I got when somebody sent me the answers already. Thank you. All right, so first of all, you use the following identity. Okay, so the area calculated in two different ways, right? So that is area, but the area is also H times C. Okay, we already know H, so AB equals H is 24C. So that's the relationship between A and C, right? Then then we know the parameter, right? So from the first equation, A plus B equals, right? We know that A plus B equals 120 minus C. I think we are able to get equation in C. Okay. So that means, we have identity A plus B, right? Square equals A square plus B square plus 2AB, right? So from here, you see A plus B is 120 minus C, and A squared plus B squared C squared, and AB is 24, right? 24 is become times 2, 40, 48. So what do you get? You get the equation in C. Okay. Once you find the C, then you find the AB. Okay. Yeah. So 120 square minus 240C plus C square equals C square plus 48C. C square is gone. And then you move the other term to the other side. It's 120 is 288C. So if I use a calculator, I can do the computation much quick. Okay, so that is actually is 50. Okay, yeah. So once you get C, then you get the area. Yeah, because this identity here, right? A is going to be half of AB, which is 12 times C. Okay, you already know C, so it's 120 times 50. So that'd be 600. All right. So let's take a look at the example again here, right? You have to draw the picture, introduce variables. Okay, introduce the variables. Okay. Then you write down all the given information. Okay. Write down all the given information using those variables. Then the next part is just algebra. Okay. Next part is just algebra. Right. So let's take a look at this problem. You have to probably have to draw the picture here. Okay, and it's a right triangle, XOY, right? XOY is a right triangle. Okay. And then yeah, let me draw the picture here. Step one, a picture, right? Here's X, this O, that's Y. So O is a right triangle. Yeah, it's 90 degree here. And M is a middle point, and N is also middle point. Then you connect them. Okay. Right. Then you have a O. Suppose X N. So this is going to be M. This N. So X N equals 19. And the Y M equals 22. And we have to find the X and M. Okay. Find the hypotenuse. Okay. Find hypotenuse. Hypotenuse is a C, right? So this is a C. Okay. All right. So what can do? So you are not given the direct information. If you are given uh if you're given an OX, right, or OY, then you just use the Pythagorean theory, then you find the XY, right? So my suggestion is you need to just write down it's easy to write down all the given information in variables. So this side is A, this side is B, right? So what do we are given? We are given xn. So xn is going to be 19. Okay? So xn is going to be 19. So 19 this side, right? So a square plus on half of the b square equals 19 square, right? You apply the Pythagorean theory to this right triangle, then you apply the Pythagorean theory to another triangle. And that is my. My is going to be 22 squared. So you want to find out C, okay? And which is square root of A squared plus B squared. So if you know A squared plus B squared, then you find the C. All right, then we're done. If you write all this in and you look at this two algebraic question, how do you get it, right? How do you get A squared plus B squared? You just add those two equations together. This is equation one, equation two. And when you add them together, I get on the left-hand side, 1 plus quarter is a 5 over 4. And this is a 5 over 4 b squared. And here 19 squared plus 22 squared. All right. So finally, I get a squared plus b squared equals 4 over 5. And 19 squared plus 22 squared. Okay. Okay. Then you simplify. Finally, you get C, the square root of B. Okay, after you simplified, you will get 26. So you find the 26. Okay, C is 26. 26 is an answer. Okay. So this example shows that don't just sit there. Okay, you name the variable for each side of the right triangle and write down all the identities that relate to those quantities. And using the Pythagorean theory, then you probably can figure out how to solve the problem. Yeah, so figure out the way to solve this problem. All right. Maybe you can find a general formula here. Okay, because we use a specific variable 19 and 22. I can even put let this to be mn, right? Then you can get a general formula for C. Okay. So that means if you know the length my and x, then you can get the length of the hypotenuse. Okay, so the reason we put those two specific numbers because it looks much better. Okay, but the same idea you can get a very general formula. Okay, so when you're doing exercise, you probably can write down general formula without to give a specific value. Okay, then you plug the number into the formula, you get the answer. All right. So our next problem. You see, here's another problem, right? We're given very specific numbers, 25 and 56. And we want to find the area. Okay. How to find it? So you draw the triangle first. Right? This is A, that's B, and C. So C is 25. So the parameter A plus B plus 25 is equal to 56. Right? So you're given this information A plus B, that would be 31, right? Yes, 31. Right, so what do we want to find out? We want to find out A times B divided by 2. Right? Can you do that? Can you use it as an algebra equation to solve it? And once you get the answers, please post it. right? We want to find the A times B. We are given A plus B equals 31. So we have to use the hidden equation by the Pythagorean theory. Okay. Right? The equation says that A squared plus B squared equals C squared. Right? C squared, C is 25. Okay. So we know A plus B, so you just square it. So from this identity, you will see that A plus B is 31. A squared plus B squared is 25 and plus 2AB. So from here, find A plus B. Okay. So A plus B equals 31 squared minus 25 squared. And if divided by 2, but if you want to find the area, they have to AB divided by 2. So you put 2 here. Right. Right? Then you solve the problem. Okay. So the area will be 84. Okay. Okay, so those are the problems I want to discuss here. Now I'm going to discuss some, I'll give you the problem and let you to try to do it in the class first. Then we discuss, okay? So exercise for class discussion. Okay, so here's the problem. I hope you already know how to do it, right? So find the perimeter of the right triangle. If you know the hypotenuse is 2 and the area is 1. Okay. Yeah, please do this. Step 1, you draw the graph, right? Now, if you memorize the formula we got, then you probably can solve it quickly, right? Right? You want to find your parameter, right? So this is a homogeneous 2 is A and B. Right? Right? So if you forget the formula, then use the algebraic identity to solve the problem. Otherwise, use the formula here. A is the square C squared plus 4A plus C. Okay, so that will be C is a 2 squared plus 4. The area is 1. Yeah, so that's a 2 squared 2 plus 2. Yes. Okay, so everybody get the right answer. So the second problem. Okay. A right triangle has hypotenuse 25 and perimeter 56 to find the area. All right. If you're in class, please submit your answer. Okay, if you finish it. All right. Sounds like everybody got right answer. Okay. So I'm going to show you now. Suppose you forgot formula, right? And you should know the formula for the Pythagorean theory, right? So you know the hypotenuse 25, and you know the pyramid, okay, equals 56, right? So this is a problem we did already. So a plus b is 31, and from here you get a plus a times b, okay? So the identity, right? 31 square equals a plus b square equals a square plus b square plus 2ab. And from here, a square plus b square is c square. It's 25 square and plus 2ab. So from here, you get a times b. Okay. So a times b is going to be 31 square, 25 square divided by 2. So if it's divided by 4, then you get the area. Okay. Yeah, so that'll be 84. Yeah, we did this before. And now, how about the next problem? The side lengths of the right triangle are integers. One leg has length of 11. Find the parameter. Right? Find the parameter. All right, for this problem, right? For this problem, if you memorize some of the special triangles, then you probably solve the problem right away. Okay? Yeah. So otherwise, it's challenging. Okay, we know that 11 square minus 60 square is 61 square. Okay. Right, indeed that is true. Then then if you know this true, then the parameter is gonna be 11 plus 60 plus 61. That is 132. But the question is, how do I know that, right? Well, I suggest you to memorize the few important right right triangles. Okay. And I think you have a much better memory than I do, then that will speed up to solve the problem. Otherwise, yeah, sometimes the best in guess in the try. Okay. Uh yeah. Like how do you do that without knowing this? Okay, this is a 11, right? And this is a let's call it C, this is A, right? Or B. Okay, let's use A here. So we know that C squared minus A squared equals 11 squared. Right? Then C minus A, C plus A is going to be 11 squared. Now, what does it tell you? Okay, so from here, you can actually can solve it. Okay, you know why? Because 11 is special. It's a 11 is a very special number. Okay, it's a prime number. So the only possible choice is a minus c equals 1, and a plus c or c plus a is going to be 11 squared. That's 121. Okay, then from here you can solve a and the c. Okay, yeah. So c, you add them together, 2c is going to be 122. C is given 61. Okay. And then if you use subtraction and the 2a equals 120, that means a equals 60. Okay. So we solve the problem. Right? Yeah, we assume that a, b, c are integers. And on the left-hand side, you can factor c squared minus a squared. On the right-hand side, it's 11 squared. 11 is a prime number. Okay, so that forces c minus a to be 1, c plus a is 11 squared. All right, take a look at the next problem. Two vertical poles are 16 feet apart. One pole is 50 feet tall and the other one is 20 feet tall. Find the distance between the tops. So what you should do, right? Step 1, you draw the graph. Okay. Once you draw the graph, the problem becomes easier. Okay, we see that Alex is always, give me the answer very quickly. It's 120, right? Okay, so you draw the graph. Okay, and that is a 16. It's a 15, 50 is 20, right? So what do you do? Just apply the Pythagorean theory. And this is the A, right? And that's 16. And this is will be 30. Okay, then just apply the Pythagorean theory. The distance is going to be square root of 16 squared plus 30 squared. Right. So we got 136. No, that's 260. Yeah, 256 plus 900. So we're lucky we got 34. Okay. All right, so that is a trivial problem. You just need to draw the addition lines, right? Then you figure it out. How about the next problem? You have to still have to draw the graph too. So quadrilateral A, B, C, D. Right. Oh, it's 130. Yeah, I'm copying one. Right. It's 100. Let's see. That's a 34 square. That's a 34. Yeah, 34. 34 square is going to be 1,156. Yes. Okay. Yeah. Yeah, the answer from previous one is just as a primate. Find the primate. It's going 132. Yes, we already got. Yeah. Okay, so let's take a look at this problem. And step one, you have to draw the quadrilateral. Okay. So quadrilateral, right? This is a 90 degree, it's a B. Okay. So AB is going to be 16, right? BC is going to be shorter. Maybe here's 12, right? BC. Okay, that's 12. Okay. Then CD and the DA is 21, 29. So maybe it looks like that. 21, DA, right? 29. Okay, and you want to find the area, right? So step one by the Pythagorean theory, and you find out this, right? AC is going to square 16 square plus 12 square, right? And that'll be 20 square, okay? And it's better just use this. It's a 4 times 4. Here's a 4 times 3. So then 4 square be taken out, just 4. And that'll be 5. So it's 4 times 5 is 20. All right, so you find the AC first. But you look at the ACD, okay? ADC or ACD. So this side is 20, right? In general, okay? So if the first thing we try and double check is whether this is a special right triangle. Okay, if it's special right triangle, then the problem is much easier. Okay. If not, we have to learn another formula. If because the triangle ABAACD is already fixed. Okay, so we are lucky here. 20 square plus 21 square equals 29 square. So it's a right triangle. Okay, so that means you can find the area easily, right? For a right triangle. So the area of this quadrilateral ABCD, this is the area of this triangle. All right, that's 12 times 16. And then the area the other one, it's 21 or 20 divided by 2. All right. And the first you got 96 and 210. The sum is going to be 306. 306. That's great. Look sounds is correct. Okay. Yeah, maybe just one more problems. And we're done. Okay. A right triangle has the integer length a less b than c, and a plus c equals 249, and find its area. Okay, this is maybe it's the last problem we can discuss here. You were told that this is a right triangle, right? Okay. Yeah, give you more time to think about. Okay. All right. So are you done? All right. So you're not given too much information. So A plus C is 49, right? It's a right triangle. Okay. So I guess C should be the hypotenuse, right? So A and the B and the C. Okay. But A plus C is 49. But we have this equation A squared plus B squared equals C squared. Okay. So B squared equals C squared minus A squared. So it will be C plus A and C minus A. Right? So what you really needed to know is A times B. Okay, so A is C plus A is 49 and C minus A. So this is a perfect square, right? And then you find the possible value for B, C and A. Okay, C and A. Okay, because B is a perfect B square, right? So this should be perfect square, C minus A. Okay, so you can try like that. C minus A maybe just equal 1 square, right? Then C minus A maybe 2 square. C minus A maybe 3 square, right? So it should be because left-hand side is a perfect square. So in that case, B should be equal to 7. Okay? Then C minus A equals 2 square. Okay, then B is going to be, I think, times 7 times 2. Okay, so that's only one possibility. C minus A equals 3 square and B equals 7 times 3, which is 21. Why is 7 times 3? Because using this identity, right? That's 49 is 7 square. Okay, so from here, you can find A and C because you only determine the value B, right? Right? And you already know A plus C is going to be 49. Yeah, in all the cases, it's going to be 8 plus C is 49. Okay. So from here, let's just take a look at the last one. Okay. So add them together, those two equations, add them together, and then you get 2C equals 9 plus 49 and 58. You determine the value of A. Okay. I think it's 29, right? C is 29. Yeah, C is 29 in this case. Then you have the values, right? B is 7, and you can figure out A, right? A is going to be C, yeah, C minus C minus B. Okay, so you can, yeah, because A plus B is 49. So C is going to be 49 minus 29. Okay, that'd be 20. So that's one of the sets of solutions. So I'm not going to talk about the last problem. I just say that at the beginning, you are not given all the equations you want, though there's some possibility there of different choices. So you have to look at this simple equation to see the possible values for A and B and C. Okay.